I'm Busch, CEO of Syntiant, and welcome to our video series, Edge AI Talks, where we discuss trends and technologies shaping artificial intelligence at the edge. I'm here with Wais, who is our GM of our federal business and also our product manager for our computer vision business. But today we're going to focus on the business that we do for AI for government applications. So Ethan, we just recently announced a success memo with DIU. You tell me a little bit about that.
Yeah, absolutely. So, well, first off, DIU is the Defense Innovation Unit, and that's a part of the Pentagon that is designed to bring in innovative technology at speed and scale across the DoD. And what is really great about the success memo that we got is it means a few things. First, it means that for the purposes that they were looking at, our technology works. They validated it in live exercises and realistic environments. And then it also gives us the ability to scale that out across the DoD because it has their stamp of approval.
So it's very exciting that we're proven to work in the applications. But if I had to explain to a family member or just a person on the street, why would the warfighter want Edge AI?
Absolutely.
What are the advantages? What does it help with?
AI now does so much. And what we are focusing on, the edge piece, is really pushing out what can you do with all of your devices, big or small, automating certain tasks, making them easier, making information easier to digest for the warfighter in real time. Think about you have devices that are taking in imagery, and we can, just like what we do on the commercial side with security cameras, we can detect people, we can detect vehicles, we can make sense of sounds, and we can do all of that on edge platforms, which is really key for the warfighter because oftentimes communications just don't work. And so whatever they have has to work at the edge. So it's exactly where we live as a company.
So how does that? Let's double click a little bit into it. Is how are these machine learning models that we run in edge devices different than what you'd have running in the cloud?
Yeah. So they're different in certain key ways. First, they are much smaller and they're going to run much faster. Cloud compute is, well, first off, the models that run there, it's bigger, it's just more expensive to run them, and there's latency involved. Latency not just in terms of transmitting the data to the cloud, but latency in terms of the time it takes to process that data and then send results back to the individual who needs the information, right? The AI processed results. And when they rely on cloud compute, that's incredibly expensive for them. Very similarly to how your leading smart home device companies would think about costs, the more you can run at the edge, the more you are cutting your costs. Another point that I think is also really important is the more you can cut down the amount of compute, the more you can run on a broad range of hardware. If we're able to deploy AI that is so efficient that it can run even on legacy systems, then the government can deploy it at the edge across a pretty heterogeneous compute base.
No, that's very exciting. Now, you can't pick up the news today and not hear something about, ChatGPT and OpenAI and this or that other, large language model, which are, effectively, very large transformer networks. Now, what's the analogy in the computer vision space? What are we doing? What are you doing? What are we doing around transformers? And is there an equivalent, a breakthrough? We've seen this breakthrough with transformer networks on chatbots. What is the equivalent on computer vision?
Yeah, well, and I'd broaden it out beyond just computer vision because I think there are a number of things that we can do with text, but in general, starting with computer vision, the transformer-based architectures, we can shrink them down, and we have to enable them to run at the edge. And what it means is you aren't reliant on nearly as much training data if you want to rapidly tune your models. For government applications, especially, they typically don't have a ton of information that represents the real world scenarios in which they will need these AI models. So, what we're able to do with transformer based architectures is have models that are that have learned what the real world looks like and require much less tuning when they get into scenarios that they may not have seen before. So you go from, to put it into practical terms, uh, the generation before where you would need, say, you have a new object type that you want to look for, you need tens of thousands of example images of that object type uh, to feed into the model to retrain it. Now you might need anywhere from a dozen to a couple hundred, or maybe even less, maybe just one. And what that means for the warfighter is that when they're out in the field and they need something to work, it is not a months long process to update models for them. It might take a few minutes or a few hours, and that's a game changer.
Yeah, so if I understand right, if the say we're looking for a boat or a truck or something like that, we would just need one or two images, and then using the Syntiant vision transformers, the warfighter can train a model.
Yep.
Can they do that in the field? Do they have to go back to the cloud? Where's this happen?
We enable them to do it wherever they want.
Oh,
They can do it in the field, they can do it on a laptop, or they can use our tools and do it on the cloud.
So with just a small number of pictures, maybe one, can retrain in the field and then send that out to all the cameras.
Exactly.
And then start and say, okay, I found this.
That's right. And the models that we run are small enough that when one person retrains it, they can then send that model around to other users, and it doesn't require enormous amounts of bandwidth.